Everyone is talking about AI. Some of the most important innovation is happening much closer to where the real world operates. When most people hear AI, they immediately think cloud. So why is the edge becoming such an important part of the conversation now?
It's about latency. Real-time workloads in industrial automation and robotics has really been a tailwind for running AI at the edge. And everything that I've mentioned really is a journey towards what is called a lights-out operation. That is actually a reality that is starting to happen.
What's some of the biggest mistakes that organizations make when they start an AI initiative?
AI becomes a tops-down approach, and the person who's actually going to use this on the factory floor isn't cued in until the last minute. This is really an augmentation of human capabilities, not a replacement. You need it to know what its job is, but know it really, really well.
Everyone is talking about AI, but while the headlines focus on massive models running in giant data centers, some of the most important innovation is happening much closer to where the real world operates. On factory floors, in warehouses, inside cameras, sensors, and machines that need to make decisions instantly. Today, we're joined by Ben Tan from Intel. Intel has committed to the edge with more than 45 years in embedded, 4,000 edge ecosystem partners, and 100,000 edge deployments with partners. Ben is here today to explore the rise of edge AI, why successful deployments are about more than just powerful models, and how organizations are turning artificial intelligence from a science project into measurable business value. This is Forging the Future. Welcome to the show, Ben.
Thank you. It's an honor. Thank you for having me.
Well, we've known each other a long time, so I think this is going to be a fun conversation.
A long time might be an understatement, Chris.
Yeah, that's true. Well, let's jump into it. When most people hear AI, they really immediately think cloud, right? So why is the edge becoming such an important part of the conversation now?
Around Intel, we call this the pendulum effect. On an odd and even year, you're going to find I'm going to shift all of my workload to the cloud, and another year they'll decide to shift it to the edge. And I think this is pretty much in lockstep with the costs associated with running things on the cloud versus the edge. Now, I would say that it probably has gained a little bit more visibility of late, right? Because of data sovereignty concerns, because of the data that is required to build the models. And the second is probably around tokenomics, right? Which is what happens when your hyperscaler credits run out or it becomes a bit more expensive. And lastly, it's about latency, right? Which is especially important for the area which I service for AI, which is in manufacturing and industrial operations.
That said, where are you seeing the most meaningful adoption of edge AI today?
In terms of edge AI, we've seen for probably close to a decade now, predictive maintenance being a poster child of IoT and edge, right? The second is around real-time manufacturing environments, right? So this is the ability to respond in real time to things that have gone off the rails in the manufacturing environment. The third is around worker safety. And last one is probably the one that has been the hotbed for the last 5 years for us, which is defect detection, quality inspection, the ability to ensure with a digital pair of eyes that production is on track and on time. Now, I think there are a couple of reasons why these have been continued to be extremely popular. The first is around the decline of the cost of ownership, right? So the ability to run inference execution at the edge, that has dramatically gone down in cost as the capabilities have gone up. And I think the second reason is because of software-defined factory architectures. So if you think of most factories that run on a programmable logic device, increasingly that workload is becoming software-defined. So instead of running it in a fixed function device, You now run it on a Xeon or a Core processor. And everything that I've mentioned really is a journey towards what is called a lights out operation, right? And that's a term I'm going to use quite a lot today, which means a factory that basically has zero humans inside, robots doing the work, lights off, they'll see what they need to see in the dark, feel, move, etc.
So essentially, the factory is sitting there just completely in the dark because you don't need who needs lights if you don't have any humans inside,
Exactly.
and then it's 100% automated.
Yep, it's a little bit sci-fi. If you're a sci-fi fan, you know how it goes.
Sure.
That is actually a reality that is starting to happen. I'm not saying that it's a journey that is quick. I think most of our big customers see this as a 10 to 20-year journey.
Are there such factories now?
The closest example I will provide is probably Audi, right? Audi with Siemens in 2025 actually had a lights out-ish factory. So obviously there's still, because it's a POC, you still do need humans intervening on site if things go wrong. Effectively running a car manufacturing line remotely tens, if not hundreds of miles away. I don't quote me on that. It is really a dream come true for a lot of manufacturers because you're able to just build these smaller satellite factories and have a singular point of control. Now, that's not to be confused with something like an Amazon fulfillment warehouse, which, Chris, as you know, they've been at automation for a long, long time, right? So the supply chain automation lights out in a warehouse is pretty different when you start building something as high quality as cars.
Well, I mean, what have organizations solved with AI now that they couldn't solve just a few years ago?
I think what we've seen, to my earlier point, is that the basic stuff's been pretty well solved. Predictive maintenance, basic CNN-based machine vision, basic connectivity with fixed function devices. Well, now, I would say what they're trying to solve next is really aligned with agents or agentic system, right? Because now you kind of grease the skids when you have an electronic supervisory role that is suited to catch things like model drifts or anomalies, which is not to say that the human is out of the loop, right? But it's just become more capable like a human. So agentic is basically going to be one of those key trends that we continue to look out for.
Okay, great. You have these agentic AI agents running more locally. I mean, but what does that buy you?
Really, it's speed and cost. I think it comes down to the ability to execute on tokens a lot faster in an air gap environment. Don't forget that there are some manufacturing facilities which are completely air gap from the rest of the public cloud. That's number one. And the second is cost, right? So you're not really paying for tokens to a hyperscaler or cloud service provider.
Okay, so a lot more at the edge going on. You can have agentic agents, everything else. But I mean, what's some of the biggest mistakes that organizations make when they start an AI initiative?
Often we see that AI becomes a tops-down approach from a chief AI officer, a chief data officer, a chief information officer. And the person who's actually going to use this on the factory floor isn't queued in until the last minute. So mistake number one is not getting buy-in from the stakeholders from day zero, right? That's number one. And the second that we often see is allowing these little islands of pilots to keep multiplying like rabbits without governance. So Department A and Department B and Department X and Y don't necessarily have a regular conversation because someone said, hey, let me go try out this cool little AI thing or automation thing. And you end up with these islands that will never meet because they weren't built to be collaborative, right? So that's number two. The third is something that I see very often. When a POC happens in a factory, it often is, let's take the quickest path that, let's not worry too much about upgrades, serviceability, or for that matter, security. Because if it's air gap, then let's not worry about that too much, right? But oftentimes what we see is this tug of war between the IT side, right, the traditional information technology side, and the OT side, which is the operational technology side, typically what we refer to as the factory floor. And when these two behemoths collide and decide that they each have their own security policies, right, that's when we see 6, 12, 18 months delay because of security policy reviews. So from the get-go, I think most organizations absolutely need to consider what could go wrong and who do I need buy in to actually deploy something, because the mindset has to be not only be about a pilot to a POC, but all the way through to deployment, right? So we see oftentimes delays to production because the planning was not done well upfront. The human buy-in was not done upfront. The last two are, believe it or not, people think about AI, but they don't think about actionable AI, which means what is the outcome of artificial intelligence and are the right subscribers to that outcome doing the right thing with it, right? So you can't really expect AI to do its thing without looking to the left or to the right of where AI exists. Here's a good example, right? Actionable AI could be something as simple as in a production line. If something has gone wrong, my defect rate has climbed significantly. Am I looking at a nut or bolt supplier that goes into my product? Am I looking at the soldering tips temperature, right? When I see a lot of failures on a PCB mounting or something like that. And then looking right, which is what do I do with that? Do I just mark it as an error? Do I have a robotic arm pick it up? Do I eject it from the line with a little arm? That's kind of, some of the biggest pitfalls that I've seen organizations make.
Yeah, so basically trying to work, fast and break things, but, not really taking the bigger picture into account. And I think the other point that I thought was interesting that you made was just kind of that human buy-in.
Yeah, absolutely, Chris. And we've heard horror stories. Actually, we've actually seen horror stories of people deliberately knocking stuff over because they see AI as a threat, right? So increasingly what we message is that this is really an augmentation of human capabilities, not a replacement. I think this is especially true in manufacturing and in some of the more mechanical, repetitive tasks, right? We're not here to to train a model to take over your job. We're trying to make your job easier and make you have a higher throughput level.
And are you seeing that as an outcome in the installations that you're deploying?
Yeah, I think oftentimes people will look at a camera a little bit funny. They think about privacy issues, right? So you got to make sure that things are focused in the right area without humans in the frame. In fact, we actually do drop frames in machine vision by default. It doesn't even make it to the processor. It just drops as part of pre-processing, right? So it doesn't make it to compute. Yeah, humans are a large factor and I think a greatly underestimated factor in AI deployment.
Greatly underestimated in what way?
As a friction point, right? We don't think about how the human is going to interact with AI, the human machine interface, for instance. If you are in an 8-hour shift that's relatively repetitive, the last thing you probably want is, oh, I got to learn something new or change the process I know, perhaps even for decades, so that this new AI thing can help me do a better job.
Yeah, we've had some conversations around that. Actually, if you can figure out how to make it a win-win when you bring on automation, et cetera, that actually is helping people be more productive and possibly even getting bonuses but for being more productive as a team, that then perhaps the AI components or the robotic components are actually seen more as a net positive.
We should fund that exercise, Chris, you and I.
Okay.
Some sort of a reward program.
There you go. Yeah, that'll work. Well, you had also said to me probably a few weeks back that you felt like machine vision was maybe underutilized, or that there was a lot farther that we can go with machine vision.
I think so. I absolutely think so, right? Because a lot of the first 5 years or so of machine vision, I'm not going to go back all the way to when ImageNet was created in 2006, but I think the uptick in the number of ISVs who offer machine vision solution has been really accelerating, I would say, in the last 3 years. But yet, the percentage of pilot POC to deployment has been pretty low, and there are a multitude of reasons why things don't work, right? As some of the reasons I mentioned earlier. But I have not seen this to be a technological challenge, but more of an operational challenge, right? So I think the market is absolutely there. We've kind of looked at the numbers from all the different data sources that Intel employs, and it's still going to be a market that has a very high CAGR for the next 5 years. And honestly, most of the experiments have been in the highest ROI, the top of the ROI pyramid, right? And as compute gets cheaper, guess what? It's us just as with any technology, it's going to start trickling down. So we wholly expect that more cameras, more sensors are going to be put in place in factories over the course of the next 10 years.
One of the things you mentioned was efficiency, right? So, I mean, how should companies really think about performance versus cost?
I think they're separate things. And here is the first thing. My first response is that most customers need to first define what performance is, right? What are you measuring against? Do you have that clarity of purpose of even implementing AI? You can throw as many discrete GPUs or compute you want, right, at achieving that level of performance. But as with anything you build, it's about trade-offs, right? For instance, it is much less likely you're going to build an on-premise data center or off-premise data center to host the language models that you need to get to that last 5% of performance, right? I think oftentimes it's 80 to 95% is good enough if it isn't eating into my bank. Now, let's contrast that with cost, right? And I think cost is much more closely related to ROI, because most companies, when they embark on an AI journey, and this is largely stipulated by their CFO of late, and they'll have a year or two to see if the ROI has been fulfilled, right? And it's about fitting within a certain cost envelope. And how do we fit within that cost envelope? Most commonly, it's Chris, as you know, right? Let's draw an architectural diagram as to how we would solve this. How much hardware do we need to buy? How much software licenses do we need to buy? How much SaaS expenses and additional human costs we need to be considering that adds up to this total bill, right? So it's cost is something where it's a sweet spot that one aims for, right? But we often tell our customers it's also not about perfection the first time. Rather, it's about making sure it's adopting, right? So really, performance is here, right? You can throw compute at it to solve, but you need to know what you're measuring. Whereas cost is what is a threshold at which you are comfortable getting the ROI at this level of performance. That's the way most of our customers and how we talk to our customers about it.
Well, I mean, are we moving toward, a world where efficiency is just as important as raw AI capability?
Yeah, absolutely. I think you hit the nail on the head, right? So let's consider power requirements, and I think we've all heard some horror stories of farmland getting razed over to build data centers, or electrical lines being run over private land just to power some huge data center somewhere in the middle of nowhere. I don't need to get into specific examples, but I think the environmental and the human impacts of just building out to up the AI game, I think is something that has come to the forefront. For us as Intel, I think we are here to provide an alternative power efficient solution, right? So in 2026, we are all about performance per watt. And this is where, if you think about a large language model with multiple billions of parameters that runs in the cloud, can we actually have smaller domain specific models, right? What I call smaller pieces of bricks with specialized capabilities that run on the edge. So when you run a model, you don't need a model that is responsible for inspecting a PCB board to know about the stock market or the weather, right? or how to make chocolate cake. You needed to know what its job is, but know it really, really well. I think the industry is moving towards efficiencies through smaller models that give you a much higher return on your power consumption. And for us, it's lower complexity with edge deployments, right? Which means as a company, you're focusing more on the actual problem rather than trying to deal with complexities of edge deployment. So it's really the big brain to a small brain concept, a series of small brain concepts, which we believe will drive the next chapter of efficiencies.
If you are enjoying this conversation, don't miss what's next. Subscribe to Forging the Future at softtek.com/FTF, and we'll send you our ultimate guide to Edge AI. Learn how to get started with Edge AI, how Edge AI is reshaping the business landscape, and plus you'll get a checklist to evaluate your Edge AI readiness. Thanks for tuning in, and subscribe now. Well, I mean, I guess that isn't that a little bit of an insurance policy against the robots taking over the world. We don't want them to have. We don't want every single thing to have a big brain, right? You know, like you said, it doesn't need to know how to do everything and anything. And if you look at the animal kingdom, you know, I mean, there's various levels of intelligence across the animal kingdom. A bee only needs to know how to pollinate a flower and bring the pollen back and make honey, right? You know, it doesn't need to know anything else, right? So at the edge, the models can be very small. And I think that what a lot of people don't realize is you don't need these large frontier models. You don't need, a bunch of NVIDIA GPUs for a lot of things, right? And that a lot of AI is actually being done at the edge on Intel chips, for example.
It is honestly a misconception that we have to correct every other meeting, right? Because I think the world's been fed a lot of you need a discrete GPU to be able to do these things. And just this morning we saw a customer who was running a ResNet 50 model on a discrete GPU, and that gave many of us in the room quite a bit of a pause to ask, did you not know you can run this on something that is a fraction of the price and probably 1/5 in terms of energy consumption?
It's kind of like hopping in your Lamborghini to go to the grocery store. I don't know.
Isn't that what you do, though, Chris?
Yeah, I know. Whenever I can. Yeah, I mean, it's just basically matching the scale of the problem to the technology, right? So
we are definitely in the last 5 years highly over-indexed on there's been this build out, this massive build out of training, right? And now we are sort of in the age of inference where the CPU's kind of taken a bit of the center stage of late. I think it's kind of reflected in how Intel conducts itself, what the street is saying, and things like that. So we're thrilled about that. The key benefit to that is around performance per watt. Now, if you asked me this question 10 years ago, would I have imagined that at some point in the future of Intel, we are power efficient? My answer would have been very different, right?
People need to realize that there's a lot you can do on a little bit of hardware. But yeah, I mean, I guess partly that's because what you're saying is all these other custom GPU solutions are so much of a power pig now, right? Intel now looks very, very efficient.
If you say power efficient one more time, we'll have to hire you as a spokesperson, Chris.
Yeah, exactly. Well, what conversations are you having today that you weren't having 2 years ago?
The buzz of late has really been around what generative AI in general, right? So everything that I mentioned today falls under the camp of generative AI. I think we've kind of gone that direction, honestly, a few years ago, but it just didn't come into the limelight until, I would say, 2025. I think some of it might have been perceived as science fiction, right? To be fair, the press hasn't been super kind to six-fingered humans or three-legged humans generated by we've all seen those stories, right? So I think there's a bit of tongue-in-cheek thing, but in a mission critical environment like like manufacturing, it's a little bit different. It's not as if the mistakes are people are less forgiving of mistakes, right? But I think that the data points do prove that the benefits are starting to be peeking out of the clouds, if you will. Now, having said that, I think customers also are increasingly understanding that the business case is down to having a sustainable value, right? So it's built on data scale, it's built on implementation discipline, it's built on process integration. So for us, it's about data scale, right? Because AI improves when it learns from the data that you have. We often need to have those conversations with customers because they are not investing enough in implementation discipline, right? It's how do you actually integrate that cleanly with your existing workflow? How do you actually have reliable performance regardless of which shift is operating, right? Then there is the process integration, right? So when AI is built into natively in the process itself, rather than as a sidecar implementation, all these inline AI native conversations are happening because people have seen the upside of what generative AI can bring to the table, right? So organizations that build durable business cases knows that these pockets of value are built over time, right? So they're not optimizing for a month, a quarter, or 2 quarters, right? They are really investing for the 5 to 10 year horizon. And the more people understand this, the more open the conversations have become.
Well, you mentioned that a lot of this is around generative AI. And of course, for me, Gen AI is creating images and documents and slideshows and things like that. But I mean, I wouldn't think that there would be generative AI in an industrial setting.
One of the more common use cases you'll see is code generation. So you know what a PLC is, a programmable logic controller, right? So it's a very fixed function device which requires very specialized skills to be able to do something, right? And these are the likes of Beckhoff, Siemens, Schneider, Honeywell, Rockwell. And at the end of the day, with coding agents, which is one camp of generative AI, right? You tell it what you want, and it'll come up with a custom code for that PLC, right? That's one way in which generative AI is used. The second, believe it or not, is generating defects, images or videos of product defects, because you cannot fathom every possible outcome, right? You could have seen 4 types out of 10 possible defects ever, right? What about the other 6? So you need generative AI to create those defects so you can then train your model to be able to infer. Then there is something like, even on the inference side, if you wanted to generate text or description associated with the defect it saw through a visual language model, that's also another side of generative.
Yeah, I hadn't thought about that, using the AI to generate images that you're then going to train the model on that you don't necessarily have specific examples of because they don't happen all that often. Well, where do you think we're still underestimating the impact AI will have on industrial environments?
Is probably the exponential benefit of AI, right? Once, and what triggers that exponential benefit is when legacy systems are truly connected. Now, as you can imagine, in any factory that you walk into, you'll find equipment and personnel who have been there for decades. And the whole IoT movement in industrial was always to connect and instrument these things. But the reality is that, a lot of this data gets thrown out or gets stored somewhere, and it never really gets acted upon, right? So in the industrial space, we have not really unleashed the potential of all of the data. I mean, this is, if you asked me that the same question 5 years ago, I think I would have given you the same answer. But back then I would have said, oh, we're going to solve this in 5 years, but evidently it's not solved yet, right? But the upside of that really is, this is a great opportunity. I love this because it is a great opportunity for compute vendors like Intel, right? Who is deeply invested in our ecosystem partners to be able to deliver for the future. So it really starts as reframing what is possible at the edge, right? You don't need a fleet of big GPUs to achieve outcomes with AI, right? So I think part of it is also, for me, it's a good indicator of, have we gotten there? And I say this quite often, is how does AI perform in a high mix, low volume production line, right? So as you can imagine, factories that churn out the same bottle of soft drink, PepsiCo, insert your favorite, that is not a huge challenge. Whereas if this was a pretty bespoke, so your tailor, Chris, if he had to make a bespoke suit, 3 of this suit for you and 2 for your coworker, and how do you use AI to kind of deal with that kind of stuff? Textile is probably a great example of that, right? Or engineering on demand, right? So if you had to build 15 PCBs for a customer, but they're extremely high value, right? $50,000 each. How do you actually employ AI to do that? Because how do you train? How do you train that? Train for that edge condition of what is a defect. So I think we're gonna get there at some point, right? We are pretty thrilled that the exponential effect hasn't happened in full force yet, but when it does, I think we'll be absolutely there to catch that opportunity. I think we've also underestimated how much changes we can implement in a greenfield factory. Here's an example, Chris. If I were to ask you, Chris, why do you think humanoid robots exist?
Well, because we're a human-oriented world.
It's a brownfield problem, right? All factories are built around humans. Therefore, if you had to automate something, you'd get something that's bipedal in nature, that had a twisting torso, twisting neck, same manipulation, right, to fit that. But what if you are building a new factory? Does it have to have 8, 10-foot ceilings? Or do I just need something that is 2 feet high and robots on wheels just do their jobs? This is a little bit of a knock-on effect of AI, right? The fact that if you build something new and you have the brains to do it, are we constrained by the legacy physical environment for manufacturing?
It is interesting, right? Because it's really taking a step back and going, well, what does the factory of the future look like? And like you said earlier, lights out, or, maybe it only has a 3-foot ceiling. It doesn't have to have a 10 or 12-foot ceiling. Maybe it's stacked in some strange way, or whatever, but it's, as long as it's optimized for, the automation, instead of optimized for humans to be able to, walk through it. So Ben, what trends are you paying the closest attention to right now?
The way I'd answer that question really is looking at what constitutes the AI trends, right? So I think we kind of look at it in slices of awareness, understanding, decision, and action, right? And if you kind of use that framework to assess the trends that we tend to pay attention to, it's really, number one, AI architectures, right? So things like MOE, or mixture of experts, world models, multimodality, and the last one, multimodality, is absolutely something we've done with audio and video inputs on defect detection. So architectures is one that we tend to look at. Or what are the AI architectures which would take the world or the industrial sector by storm next? And the second is around frontier models, right? So we wholly expect that, insofar as inference is concerned, we're going to, our customers are going to pick frontier models. The question is, how do we optimize those models that work best on Intel silicon, right? And I think that is, to the earlier example I provided around software-defined automation and code generation to program PLCs. I think we are paying very close attention to frontier models, because I think that's probably the largest, the most significant use case with LLMs we're seeing, both directly and indirectly via our customers. I think a third trend that I tend to kind of pay attention to is cost, and it's not so much about, oh gosh, everything has become super expensive because of memory constraints and all that. As I said earlier, right, when it comes to cost, it's about weighing the size of the model versus the compute capability for you to be able to run your AI workloads at the edge. So I'm actually thrilled that the evolution has allowed us to size the right tool for the job with smaller models, right? And I don't think, if we were asked this question years ago, I think we would have just said, let's just run everything in the cloud in the LLM because that's the best way to approach it, right? But the market, and you'll see this on Hugging Face, right? North of 2.5 million models on Hugging Face. It's just a crazy explosion right now, right? So as we think of this through, it's not just about let's run it in the cloud, let's run it on the edge. And a few months ago, we announced something called SuperClaw, right? Which is a way to really conserve tokens by having a hybrid edge to cloud market AI capability. Really, that enables you to apply a slider scale of I have less memory, less compute on the edge, but I still want to generate my tokens. I don't want to 100% rely on the cloud to be able to do this, right? So SuperClaw is going to be an exciting program that we'll unveil in more detail in the second half of the year. But its premise is really how do you actually have an edge to cloud hybrid of token generation capabilities? So that's a trend. It's a trend that we've observed because of the tokenomics, and that's our response to how we address the market.
You've spent a long time watching technology evolve. I mean, what does excite you the most about this current moment?
I guess I'll respond to this both as a supplier and as a partner, right? And I think the simple thing is, as a supplier, I think we are thrilled that compute is taking center stage, right? Look at the attention the industry has given to Intel, and we're all pretty thrilled about the direction under the new leadership. I think it's a different level of energy of late, and to be working here during this time is as good as any. So I think the world paying more attention to inference, it has been in the last year has been a real morale booster around here, right? But more importantly, as a partner, right? So whether it is a partner to an end user, to an OEM, to an ISV, to a GSI, whatever, right? Whatever ecosystem partners I deal with, I think one of the things that is a side effect of better compute is that we are going to be solving problems in a much less bespoke manner and in a more open and interoperable and standards driven way, right? So to me, it's a lot more efficient to deal with a large number of ecosystem partners, and this is just by turning up the compute capability. I think we are able to software define a lot more. So to me, that we are at a point where compute is fully capable of doing a lot of things we couldn't imagine years ago.
Well, this is forging the future, so I'll ask one last question. What's one thing about the future of AI that you think most people aren't paying enough attention to?
No, because AI is such a buzzword, I think the biggest thing that tends to slip through the cracks, how do I define success to my business? And people think of AI, of all these technologies, and I'll come back to the a point I mentioned earlier, right, which is the operational friction. And it really starts at the C level, right? So we aren't paying attention to having organizations align for joint success. So the most successful organizations we work with are those where it almost seems like the CIO, the chief data officer, the chief AI officer are operating with a mind meld. Simply put, they are aligned on the success, the metrics, and the outcomes for their business. And not about AI, it's for the business, right? So they also understand that industrial AI or AI anything, it's not a technology initiative that says, I'm going to do this in 3 months, 6 months, and then we're going to be fine. They see it as a long-term operational transformation where they are organized around outcomes. They're not organized around how many can I deploy, right? You don't take a goal of saying I must deploy to 10 lines, 15 lines by the end of the year, right? They measure success in throughput and quality and lowered cost. Again, I don't think it's unique to industrial, but those are the key metrics, right? It's not how many pilots we've completed, how many models we built, how many times we've retrained the model. It's just about business. Successful organizations build systems that are designed to keep learning. It iterates because it's AI, it's adapting, it's improving, right? That whole systems mindset is what needs to be embraced for this to be successful. So really, it's defining what is success to one's business. I think that's the one thing that people don't think about enough.
Yeah, let's get this AI in here. Let's get this thing going. Not necessarily what the outcome is going to be, right?
Exactly. We're blinded by some of these, shiny things, right?
Well, Ben, super interesting. Thanks for spending time today.
Chris, thanks for having me. It's truly a pleasure. We've gone back over 2 decades easily, and this is the first time I've been invited to your show. So I hope to at some point come back with more of my peers.
Yeah, definitely. Or we'll do something in person, something like that. All right. Well, thanks, Ben.
All right.
AI's future won't be defined solely by what happens in the cloud. It will be shaped by the intelligence embedded in the devices, machines, and systems that power our everyday world. A big thank you to Ben Tan from Intel for joining us and sharing his perspective on Edge AI, industrial innovation, and what it takes to move from experimentation to real-world impact. And thank you for joining us on Forging the Future. Be sure to subscribe, and we'll see you next time.